Multi-cloud made simple. AWS versus Azure versus Google Cloud Services. Navigating AWS, Azure, and Google Cloud can feel like learning 3 different languages at once. Each provider has unique names for essentially the same functions, creating unnecessary confusion for developers, architects, and organizations trying to make informed cloud decisions. The reality is that most core cloud services perform similar functions across all platforms. They just have different names, slightly different features, and varying pricing models. Understanding these equivalencies is crucial for anyone working in today's multi-cloud world. The Service Translation Challenge. Take compute services as an example. AWS calls their virtual machines EC2 instances. Azure calls them virtual machines, and Google Cloud calls them compute engine. Same fundamental concept, 3 different names. Multiply this across dozens of services, and you can see why cloud navigation becomes overwhelming. This naming inconsistency isn't accidental. It's partly competitive differentiation and partly the result of different development histories. But for practitioners, it creates real friction when evaluating options or moving between platforms. Core service categories. Compute and container services. Virtual machines form the backbone of cloud infrastructure. AWS EC2, Azure Virtual Machines, and Google Compute Engine all provide scalable virtual servers, but with different instance types, pricing models, and management interfaces. Container orchestration shows interesting variations. While AWS offers both ECS and EKS, Azure provides container service and AKS, and Google Cloud focuses heavily on GKE. The Kubernetes ecosystem has created more standardization here, but platform-specific features still differentiate the offerings. Serverless computing represents another convergence point. AWS Lambda, Azure Functions, and Google Cloud Functions all enable event-driven, pay-per-execution computing, though with different runtime support and integration patterns. Storage and database options. Object storage services, AWS S3, Azure Blob Storage, and Google Cloud Storage are perhaps the most functionally equivalent across platforms, yet each has unique features for data lifecycle management, security, and integration with other services. Database offerings show where platforms truly differentiate. While all 3 offer managed SQL and NoSQL options, their specific implementations, performance characteristics, and pricing models vary significantly. AWS RDS versus Azure SQL Database versus Google Cloud SQL represent different approaches to managed relational databases. Networking and security. Virtual networking capabilities are fairly mature across all platforms. AWS VPC, Azure Virtual Network, and Google Virtual Network provide similar core functionality, but with different approaches to routing, security groups, and hybrid connectivity. Identity and access management reveals philosophical differences. AWS IAM, Azure Active Directory, and Google Cloud Identity and Access Management reflect different security models and integration approaches, particularly around enterprise directory services. Platform strengths and gaps. AWS advantages. AWS often provides the most comprehensive service portfolio, particularly in emerging technology areas. Their early market entry means more mature services and extensive third-party ecosystem support. Azure integration. Azure's strength lies in enterprise integration, particularly for organizations already using Microsoft technologies. Active Directory integration and Office 365 connectivity create compelling hybrid scenarios. Google Cloud innovation. Google Cloud often leads in specific technical areas like machine learning, data analytics, and Kubernetes orchestration, leveraging Google's internal technology expertise. Multi-cloud strategy implications. Understanding service equivalencies enables several strategic approaches. Workload optimization becomes possible when you can map identical functions across providers and choose the best implementation for specific use cases. Vendor risk mitigation requires understanding which services have equivalent alternatives and which represent platform lock-in risks. Cost optimization often involves comparing functionally equivalent services across providers, since pricing models and performance characteristics can vary significantly. Skills transferability improves when teams understand how their knowledge applies across different cloud platforms. Practical application. For cloud architects designing multi-cloud strategies, this service mapping enables informed architectural decisions. Instead of choosing platforms based on marketing or familiarity, architects can evaluate actual technical capabilities and cost structures. DevOps engineers managing cross-cloud pipelines need this translation layer to build deployment automation that works across multiple providers. Understanding service equivalencies enables more portable infrastructure as a code implementations. For professionals pursuing cloud certifications, understanding these mappings accelerates learning. Concepts learned on one platform transfer more easily when you understand the equivalent services elsewhere. The hidden complexity. While service names and basic functions may be equivalent, the implementation details often matter enormously. Performance characteristics, integration patterns, pricing models, and operational complexity can vary significantly between functionally similar services. This cheat sheet provides the starting point for evaluation, not the complete analysis. Each service comparison requires deeper investigation of specific requirements, but having the basic mapping eliminates the initial confusion about what services exist and how they relate. Strategic value. Multi-cloud competence has become a competitive advantage. Organizations that can effectively leverage multiple cloud providers, avoid vendor lock-in, optimize costs, and access best-of-breed services regardless of provider. The key is treating cloud providers as infrastructure vendors rather than technology platforms. When you understand service equivalencies, you can make decisions based on technical merit and business value rather than marketing positioning. This comprehensive service mapping transforms cloud platform selection from a confusing maze of proprietary names into a structured comparison of capabilities and trade-offs. Whether you're designing new architectures or evaluating existing deployments, understanding these equivalencies is fundamental to effective cloud strategy.